This is the practice page for 9.7. For each pair of similar triangles, find the value of each variable. So we know all of the sides on this triangle. We know none of the sides on this triangle. These triangles are clearly similar by angle. Now, they tell you the perimeter of this triangle is 30. How about we do this problem? We just did one where the perimeter was 30. Not that it makes a huge difference, but these two triangles are similar by angle as well. Now, they tell you that the perimeter of this triangle is 48. And this sure looks like the bigger triangle. What's the perimeter of this one? 12 plus 12 plus 8. Remember, perimeters just add up the sides. Plus the perimeter of that guy's 32. Your scale factor is going to be the same as the ratio of the perimeters. So 32 compared with 48. That's your scale factor. It's 2/3. These sides are 2/3 of the lengths of those sides. That's what this means. Now you just need to know what goes with what. It's not always left side with left side, right side with right side, bottom with bottom. It's not always that way. It is that way in this case. It's because of the marks. One arc, two arcs, one arc, two arcs. So these definitely go together. 8 to z equals 2/3. Notice how my smallest number's on the top. 8 is definitely from the smallest triangle, so z is bigger than 8. 12 to x equals 2/3 also. 12 to y is going to equal 2/3. So you don't even really need to write this proportion as well. Obviously, when you cross multiply, the value of y is going to match whatever x is. These triangles are isosceles, is what that means. So we're cross multiplying now. We're going to take 8 times 3, that's 24, and 24 divided by 2 is 12. We're going to take 12 times 3, which is 36, and we're going to do 36 divided by 2. So that's 18. So y is also 18. Okay, double check. 18, 18, 12. 18, 18 is 36. 36 and 12, 48. That makes sense. These three sides needed to add to 48. Number 3, let's determine the scale factor for each pair of similar triangles. They're telling you these are similar, so you don't need to check the ratios. You just need to write a ratio of corresponding sides. Smallest goes with smallest. That's the easiest way to do it. So I'm going to take 16 from there. I'm going to take 24 from here. So your scale factor is this guy reduced. 8 goes into both. 2/3. Very popular fraction, evidently, 2/3. This guy, same type of deal. No, look at this. Another problem with 2/3 in it. Could we not find another ratio somewhere? My goodness. Okay, so that one's got 2/3 in it. I'm tired of looking at 2/3. Let's do number 6. Let's say you have two triangles that are similar. Find the scale factor of triangle XYZ to triangle DEF. Or they're not saying find it. They're telling you it is. So our scale factor is 3/5. That's your small triangle. That's your big triangle. Small to big, because it's written small to big. The lengths of the sides of triangle XYZ are 15, 12, and 12. Find the perimeter of the big triangle. So perimeter of the big triangle is obviously going to go with the big number. You need to put the perimeter of the small triangle here. You just got to figure out what it is. – 15, 12, and 12. 39. Now, cross multiplying obviously works here, but I know that 3 times 13 gives me 39. What's 5 times 13? That's a way you can get your answer quicker.